guys, Mr. Kozlov here. For our lesson today, we only have 4 simple slides. We're going to talk about prime and composite numbers. So the first thing that you have to know are what is a prime number and what is a composite number. Well, a prime number is a whole number greater than 1 that has exactly 2 factors. And I mean exactly 2 factors. Itself and the number 1. So 1 times whatever that number is, those are the only factors. If you remember what a factor are 2 numbers that can be multiplied together to equal a number. So in other words, if I was looking at 14, 14's factors could be 1 and 14, because 1 times 14 is 14, but also 2 and 7. 2 times 7 is 14. Therefore, 14 is not a prime number. 14 would be a composite number, because the definition of a composite number is a whole number greater than 1 that has more than 2 whole number factors. Okay? So once again, prime number, exactly 2 factors. So I'm going to underline exactly. I try to underline, but this isn't working. So exactly 2 factors. Okay? Test ourselves. The number 20. 20 is an even number. So one of the things to remember is any even number other than the number 2 cannot be a prime number, because it will have more than exactly 2 factors. If it's divisible by 2, then that would be 2 times 10. So this number would be a composite number. 23 has only and exactly 2 factors, the number 1 and the number 23. That would be prime. 37. Can you think of a number that is divisible by 37? No. So 1 and 37 are the only factors. Now the number 1 is tricky. You think about the number 1, how many factors does the number 1 have? Well, the only thing to multiply to get to 1 is 1. So the number 1 only has 1 factor, and that does not meet our criteria of having exactly 2 factors. So the number 1 is not composite and not prime. And it's the only number like that. The number 16, well, 16 actually has 3 factors. It has 5 factors, sorry. 1 and 16, right? Because 1 times 16. It also could be 2 times 8, and then 4 times 4. So what I want you to remember is, we don't write the number 4 twice. That's only 1 factor multiplied by itself. So the number 16 actually has 5 factors. That would make it composite. Same story with 25. 1 and 25, but then also 5 times 5. So that has 3 factors. That would make it composite. What I've also done for you is given you a chart from 1 through 100, and I have highlighted all of the prime numbers. Please keep your notes together. If you print this, it's just going to kind of look gray, but if you look on the computer, you can see that they are all highlighted. If you have a color printer at home, they'll stay yellow. Otherwise, they're going to be kind of grayish. But these are all the prime numbers. And the ones that we are going to concentrate on this year in 6th grade are these first 2 lines of prime numbers, 2, 3, 5, 7, 11, 13, 17, and 19. That means there are 8 numbers that you are going to need to know in order to be successful this year. The rest of these, keep this chart so you know what they are. All right, last but not least, let's move on to our last couple of slides. And we are going to look at divisibility rules. Divisibility rules are very cool. because they tell you for larger numbers whether they actually are prime or composite. 2 is pretty simple. If the last digit is 2, the last digit meaning the last digit in the ones place, okay? That means that it is divisible by 2. 0, 2, 4, 6, or 8. That means that they are all divisible by 2 because they're even numbers. There's also a rule for 3. If the sum of the digits are divisible by 3, okay? That's kind of funky, but let's take the number 48. If I add 4 plus 8, I get 12. And is 12 divisible by 3? Yes, it is. So automatically you know that that is divisible by 3. It also happens to be an even number. So we know it's divisible by 2. So if I skip down here to the rule of 6s, if the number is divisible by 2 and 3, then it is automatically divisible by 6. 2, 3, 6. Okay? Then we go back up here to 4. If the last 2 digits are divisible by 4, then the whole number is divisible by 4. And if there are only 2 digits in the number, then you use those 2 digits. And of course, 48 is divisible by 4. That would be 12 times. So it's also divisible by 4. The number 8 is a little more tricky, and I don't like to use 8 a lot because for 8 it's the last 3 digits are divisible by 8. Well, there aren't even 3 digits in 48. So you just have to divide 48 by 8. And of course 8 times 6 is 48, so that's divisible by 8. So this rule right here, I'm just going to kind of throw a question mark. It works if you have a 3-digit number. Okay? So, moving on. 0 and 5 for the number 5, pretty simple. 5, 10, 15, 20, 25, 30. So if it's the last digit is a 0 or 5, like in the case of 600, that would be divisible by 5. The number 9 is also kind of cool. The number 3 is the sum of the digits. Remember, we added the 4 and the 8. So the number 9 is if the sum of the digits are divisible by 9. So that means we're actually adding digits, like the number 108. If I look at the number 108, I don't necessarily know that's divisible by 9. However, if I take 8 plus 0 plus 1, that equals 9. And is 9 divisible by 9? Yeah. So I know that number is divisible by 9. Okay? There you have it. I added the number 12 on here just because that's also kind of cool. If the number is divisible by 3 and 4, then it is divisible by 12. But for the most part, we're going to be talking about 0, or I should say 2 through 10. And there you have it, divisibility rules.